This is the BBC.
This podcast is supported by advertising outside the UK.
Thanks for downloading the In Our Time podcast. For more details about In Our Time and for our terms of use, please go to bbc.co.uk/Radio 4. I hope you enjoy the programme. Hello, the book of Genesis resounds with a terrible act of punishment carried out by an angry God. And the mechanism with which this is carried out is a catastrophic flood which wipes out evil on earth. Many ancient civilizations believed extreme meteorological phenomena like thunder and lightning, hailstones and even meteors were acts of divine intervention. Running parallel with this belief was a desire to understand and explain the natural world through rational inquiry and observation. This relationship between the natural world, divinity and reason has fascinated philosophers, artists and scientists from antiquity to our own time. Aristotle, for example, coined the phrase meteorology, but to what extent did he link meteorological events to the cosmos and the gods? How did the development of instrumentation during the Renaissance aid the prediction of weather events? Why did 18th century writers such as Keats feel that these scientific advances stripped the sky of its mystique and romance? And why does meteorology continue to fascinate and mystify us to this day? With me to discuss this is Liebe Taube, Director of the Whipple Museum of the History of Science at Cambridge University and author of a new book called Ancient Meteorology, Richard Hamlin, author of The Invention of Clouds, and Vladimir Yankovic, Wellcome Research Lecturer at the Centre for the History of Science, Technology and Medicine at Manchester University and author of Reading the Skies. Vladimir Yankovic, what are the origins of the study of meteorology?
Probably very hard to say exactly at which point we can talk about meteorology as a systematic body of knowledge. But no doubt there is a long history of human interest in weather phenomena, partly because agriculture, partly because of the interest of prediction of weather, obviously, and partly because of all kinds of human activities related to the weather, such as military campaigns.
Yeah, but let's try to identify when you think it started. When did it start? From which civilizations do we have the first evidence that meteorology was being studied in any sense that we know it now?
Babylonians have a long series of observation of both astronomical and meteorological phenomena written in tablets. They record different phenomena such as rain, dew, storms, also shooting stars, extraordinary appearances in the skies and so forth. It's not quite clear what they want with these information, apart from having them listed or collected in this large numbers of tablets. And they certainly don't have any theory to back what they observe, but they are capable of a very accurate prediction of things such as the solar and lunar eclipses. They're not very successful with prediction of the weather, obviously, but they certainly do make a very, very long record of weather.
What date are we talking about here?
We're talking to 2000 BC.
Richard Hamlin, let's move across the world to the ancient Chinese civilization, which also... Was there any connection between the Babylonians and the Chinese?
It's very hard to say. I mean, it'd be lovely if there was. I mean, we certainly know there was a connection between the Romans and the ancient Chinese. But just adding to what Vladimir has said, I mean, again in China, China as a landscape is incredibly complex geographically and meteorologically. And for most of its early history was divided into constantly warring princely states that were very closely neighbouring to each other in the mountainous regions. And from a very early period, sort of 14th century BC, had developed incredibly centralised, militaristic, bureaucratic, stately structures in which knowledge was power, really, and they were creating military intelligence, military technology, which included meteorological, and they developed instruments such as snow gauges, which were bamboo cages, which were put up in the high parts of the territories to collect the snow. And
how did that work then? You could go a bamboo cage in the high territories, then what?
And it fills up with snow, and there's a snowdrift, and then a poor local official has to gauge the amount of snow in there and send a report into what was effectively the Minister of Works, who would then plan budgets for road building and flood defences, because snowfall is a very good indicator, obviously, of what's going to happen when it thaws. And we have records, weather reports going back to 1400 BC. This is before the invention of paper. This is like Vladimir's clay tablets in Babylonian times. This is scratched on pieces of bone, on fragments of tortoiseshell. Beautiful objects in themselves, but an extraordinary intensity of record-keeping in this period.
Where did yin-yang fit into this? The female principle yin, the masculine principle yang, which seems to have gone right through Chinese philosophy and society at that time.
Well, there's
yin and yang.
Yin and yang. There's first of all, there's the 5 essential elements or active principles of wood, earth, fire, water, and metal, and all of these are in a cyclical relationship of conquest, mutual conquest, so that, for example, metal conquers wood because it can cut through it.
It's that old game, isn't it?
It is.
Yeah.
It is. Papers,
It's paper,
stone, scissors. Exactly. And it makes a circular arrangement, and this implicates everything that goes on in the universe, including human action. So it's perfectly natural that dynasties should rise and fall, that neighbours should conquer one another, because there is this idea of conquest inherent in the Chinese mental world picture, and that is sort of ruled by the bigger principle of yin and yang, which is that yin is a principle which is earthbound and to do with clouds and water, and yang is a sort of male aggressive principle to do, and it is implicated with things like thunder and lightning, and there's constant balancing. This whole the idea of the universe is that it's always balances, that whenever there's an action, there's a reaction that balances it. So, for example, if there's too much of the yin rain, you get a compensating bolt of yang lightning to kind of balance things out in the atmosphere.
Well, we've been to the Babylonians and to the Chinese, and inevitably we come to the Greeks, and almost inevitably we come to Aristotle. And again, he had 4 elements, not 5, didn't he? And he completed the first known book on meteorology in 340 BC. What was his basic notion?
What he's saying is that it's a crucial part of the natural world. We have to understand what takes place in the location below the celestial bodies, and that we also have to understand how these events, phenomena, appearances that we see relate to other things as well.
And what was his basic explanation?
His basic explanation was the sorts of things that are meteorological, which for him are not just what we think of as weather phenomena, but include shooting stars.
I know
comets.
these are phenomena, but what was his explanation for the phenomena?
His explanation was that all of these things are based on 2 different exhalations, things that are arising from the Earth. He says it's very difficult to describe these things, that it's very difficult to define them precisely, and he's a little bit vague, and there's no place in the treatise where we can find a succinct definition. I think part of this is because he's saying it's very difficult
Yeah, but
to
what is he
understand.
saying, Lieber? We're not getting there yet. I mean, he's
Okay.
talking about, and I don't feel we're getting there. He's talking about the basic sublunar conditions are caused by exhalations, gaseous exhalations, as I understand it, you're the
Yes.
expert, gaseous exhalations from the Earth which move inside the bowels of the Earth, which are creating earthquakes like flatulence. He compares it with the
Yes,
human body.
exactly.
It's part of the holistic idea. That's what he's talking about, isn't he?
Yes. But, earthquakes is only one of those sorts of phenomena, which I think for us, from the modern point of view, we wouldn't consider to be part of all of this. And I think that's one of the things that's very interesting, is that he's got things that we would consider to be astronomical, like comets, also being caused by a dry exhalation, catching on fire from the motion of the celestial sphere above it and becoming ignited.
Sorry, I interrupted you, didn't mean to. Did he see Did he see what he was doing as explaining an integrated cosmos, or did he see it as evidence of intervention of or by the gods?
Absolutely not intervention by the gods. I mean, part of his program is to describe nature as being natural and not supernatural. There's not an explanation that's above nature here. It is, I think, an integrated whole for him, but he makes it clear that the links aren't always obvious. But, for instance, you referred to flatulence, and he does draw on many analogies to things that we're familiar with in our everyday experience. So this explanation that earthquakes are like a rumbling in the bowels is for him a way of explaining something that's very difficult. He warns us. It's very difficult to understand. It also comes, I think, to his idea of what the meteora are for. Why does it rain? It rains so that crops will grow and that animals will be able to eat, humans will be able to eat. So it's holistic in that sense as well.
Vladimir, when Christianity came in, conditions became associated with a single God, and they became understood as something he could use to punish an erring, sinful people. What effect did that have on the study of meteorology?
Quite a profound effect in many ways, although we find among Romans authors what we would call the providentialism, the idea that certain god, like in Greek theology, Zeus was responsible for producing storms. Zeus was in charge of thunder and lightning. We find a Christian god in charge of all meteorological phenomena, especially when they are doing something to the humanity that can be interpreted as a punishment or as an omen, as a portent of future events. So God is in charge of natural world generally, and the natural theology as a very diffuse and very broad field of understanding nature in terms of God begins with the advent of Christianity and pretty much never ends until the very late 19th century. Even today, you find a lot of people who explain natural phenomena in terms of God's interventionism.
Well, a couple of years ago, the Prince of Wales talked about the flooding in terms of an act of God, didn't he? And that is, a lot of people still interpret things in those ways. How, though, did it? You spoke of the Roman. How did this belief system, very powerful Christian belief system, affect the study of meteorology? I mean, what happened to those studying meteorology? Did they change their game? Did they change their... What happened?
It's hard to say. I think one thing that we know is that the Aristotle's work and the Aristotelian commentary up until the medieval period, up until the 14th century, remains pretty much unchanged, and people subscribe to Aristotelian views regardless of the fact that the Christianity has taken over the Western world.
So 4 elements, the exhalations,
absolutely,
and so
4
on.
elements, so forth. However, in the late 13th century, there is an increasing perception that the Aristotelian doctrines are not compatible with Christian faith, and the Paris Edict from 1277 at the University of Paris bans teaching of Aristotle, which then opens alternative viewpoints.
Vladimir talked about Aristotle being studied right up into the late Middle Ages. Jumping into the Renaissance now, the invention in the 17th century of various instruments, the thermometer, the barometer, the microscope, telescope, and all that sort of thing, Liebertome, that changed the study of meteorology. Can you explain how?
Well, yes, but I think it's not only, I think it's more in the 19th century that we see those changes.
I'd like to stay in the 17th century.
Stay in the 17th century. Yeah. It's once again coming, I think, from an interest in natural philosophy. Just as Aristotle was motivated by a more general interest than just the weather, I think that the way that the scientific instruments that relate, in our view, to meteorology, like the barometer, the thermometer, etc., were motivated by more general interest in, for instance, the weight of the air. Does the air weigh something? How do we measure temperature? Not so much being linked to either explaining weather at that period in time or to predicting weather either. I think that is coming later.
Is this dependent, Richard Hamlin, on Descartes' view, which took forward or took on or undermined Aristotle's view of what stuff was out there, that it wasn't 4 elements at all?
Yes, I mean, Descartes' building on the work of earlier writers like Galileo and Kepler and so on, but he certainly rejects the Aristotelian view of the universe, that there are 2 distinct regions, the celestial region above the moon, which is unchanging and perfect and incorruptible, and moves in a kind of stately series of concentric rings, and the terrestrial region below the moon, which is where all the change occurs, and that's where the 4 elements live, and for Aristotle, the 4 elements are always trying to get to their rightful place, their rightful zone, which is in a concentric organisation with the Earth at the centre. And for him, all weather and earthquakes and volcanoes occur as a result of the sort of the sad attempts of the elements to get back to their rightful place. And that's why flames always burn upwards, because they're trying to get to their home above the air, and that's why water finds its own level, because it's trying to spread itself out.
It's a good explanation, isn't it? I mean,
it works.
Right,
but it certainly works, but not for Descartes, who completely rejected this idea that you need distinct modes of science for understanding each of these two celestial and terrestrial regions. And he thought you needed just the same kind of overall approach, the same physics, the same mathematics to explain everything. And he also rejected the four elements and said that basically all matter in the universe, including the stars, the rocks, the water on Earth, all of this stuff is made from essentially the same matter. It may come in different sizes, but it's essentially the same matter. So we need the same science, the same approach, the same maths to account for everything. And he thought you could account for everything.
One of the things that was happening in the West at this time, though, Liebertorb, is that quite a bit of the work is being done by people all over the place, i.e. amateurs, yes. Often clergymen.
Yes.
So let's take clergymen, or men of great religious feeling, like Luke Howard, who was a Quaker, then a Plymouth Brethren. And so he's working away at meteorology. He's working away at the secular observation, as it were, and yet he's still a devout Christian, and he's holding these two things quite comfortably, as many clergymen are, together. Can you just discuss that a bit?
Well, I think that, as you said, there's this great amateur tradition, particularly in the 19th century, that centers on the availability of data, weather's out there, it's easy to get at, and also the instruments that are used to collect the data and also to help make measurements. And I think the quantification, as has already been said, is important in this period. And I think that that's done without necessarily any reference to what's going on theologically. No matter who you are, you can do it. And I think that that's one of the very interesting things that's going on in that period, that it is rather democratic in that way.
Do you think that as the late 18th century, early 19th century goes on, this data is adding up to something that matters? Lieber. No, don't look at him. You, Lieber.
Oh, me?
Yeah.
Do I think that it's adding up to something that matters? Depends what we think of as matters. Yes, I think in terms of being able to describe weather conditions and climate over a long period of time, whether or not it means that we're going to be able to make accurate weather predictions tomorrow or next week, I don't think so.
But we're still on this. We're running these two things, aren't we? We're running understanding and prediction, and it's adding to understanding. Luke Howard, for instance, I have learned while preparing for this program, developed an idea of cloud classifications. Yes. Can you talk about that, Richard?
Yeah,
and why it's important and how he did it.
Can I just go back to the question of his religious life as well?
Yeah, that would be very interesting.
Because for Luke Howard, certainly his scientific life was a part of his religious life. He described what he was doing with the clouds as a respectful ordering of God's creation. For him, this is a way of offering praise. He's a very devotional scientist in that respect. And this was recognized by his contemporaries. But certainly for Howard, he was aware that meteorology had thus far got not very far, and that he wanted to establish it as a science.
Give people a date to know where we are now.
Sorry, he classifies the clouds in 1802.
1802, that's right.
So exactly 200 years ago. And he feels that what meteorology needs is a language of classification, because all the other sciences around him are operating very, very strictly on these languages of classification. Linnaeus introduced the binomial Latin nomenclature, the naming of plants and animals and rocks and so on. And meteorology was, as Vladimir has suggested, was a slower developer than other neighbouring sciences. And this is partly because the phenomena of its studies are ungraspable. You can't take samples of clouds. You can't take a sample of a rainbow and go and study it in the lab or in the Cabinet of Curiosities. So it suffers a distinct disadvantage in the sense that although one wants to make quantitative measurements you can measure, actually you're still doing qualitative work. Luke Howard's cloud classification is intensely qualitative.
There are three sorts of clouds that he classified, aren't there?
Three basic families of cloud. The cirrus cloud, which is the highest wispy clouds made of ice crystals. The stratus cloud, which is the lowest sort of misty, spread out clouds, and cumulus clouds, which are the fluffy summer heaps. But he made the point that all of these clouds, that these three types of cloud merge into one another over time. So it's not a fixed category. It's a very mobile order. It's an extraordinary piece of science, in a way, because it doesn't seek to kind of freeze frame the sky. It allows the clouds to go and move on and have their freedom and change. I mean, the average life expectancy of a cloud is about 10 minutes. So it's a fast-footed.
It's a wonderful
science.
Trivial Pursuit. A lot of people are going to love to know that. Just a quick digression, Vladimir. This idea of Luke Howard's either coincided with or was taken up by artists of the time in this country. Goethe also did, but Constable, let's stick with him. He said painting is a branch of science and should be pursued as such, and he did studies of clouds. I mean, he did quite a lot in the Lake District, as happened. There's a convergence, though, which is very interesting, because a person like Keats objected very much to this and talked about Newton unweaving the rainbow. So science enters into romantic art quite powerfully at that point, doesn't it?
Yes. Well, late 18th century really is a time of a cultural, social, political upheaval throughout Europe, and meteorology, for some people like Shelley, like Wordsworth, exemplifies this unstable world, just like it exemplified the instability in the Aristotle's theoretical framework. So meteors, those aleatory, fleeting, changing, very short-lived phenomena, they're defined as being short-lived, they epitomize the romantic sort of bid for insisting on instability, insisting on shifting grounds of ambiguity and sensationalism, obviously. And Constable certainly, taking the lead from Luke Howard, very much interested to recreate that fleetingness of clouds and somehow to fix them and to use them as a metaphor for a larger...
And to understand them as well.
Absolutely.
I mean, Constable's watchword was, one sees nothing truly till one's understood it, which is an extraordinary comment for an artist to make. But it's not that unusual. I mean, for example, George Stubbs, the horse painter, he felt that the best way to learn to paint the outside of a horse was to drag some carcasses out onto Newmarket Heath, open them up and have a good look inside. And that helps him paint the outside of a horse, just as reading meteorology helps Constable paint clouds that he feels are not just accurate in a kind of pedestrian way, but true in the spirit of the sky in some way.
Lieber, how did, as the 19th century went on, how did meteorology, all the other sciences, chemistry, physics, wherever you look, are professionalizing, are developing, are classifying more and more, are grappling with creating technology and so on. Where's meteorology in all this? Is it still finding it difficult? I think Richard put his finger on it. You can't take samples into the lab. Is it still finding it very, very difficult to get to grips with, as it were, the scientific swing of things? It's not in the scientific swing in that sense. Is that right?
Well, I think there are certainly strong attempts to professionalize it, and some of it comes from astronomers. And it's interesting because there's a link going back to antiquity between astronomers making observations for weather prediction, and we see that also very much in the 19th century. It focused that way. But there's also this idea of having to collect a lot of data and making use of an extensive network of people collecting data, and oftentimes these are those amateurs that we mentioned earlier. Even today, there was an article in the paper yesterday saying that the United States Air Force has special combat meteorologists, and if they parachute into an area and lose their kit, then they're meant to speak to farmers and shepherds to find out what the weather conditions are and what they're likely to be.
Presuming they can speak the language of these expert linguists.
Well, I think what's fascinating about the folklore of meteorological folklore is that by the late 18th century, meteorologists, if you can call them, are so frustrated with attempts to explain atmosphere. Then they say, well, look, why don't we give up on the project of the sort of causal deterministic explanation of the atmosphere and actually go out in the field and ask those shepherds and see what they know about it? So there is this rejuvenation of the folklore that existed through the generation. And what's great about this folklore is not that it's based on theory, but rather that it's not based on theory. This is the virtue
Red Sky
of...
and Night
Exactly.
Shepherd's Delight stuff, is it?
Exactly. So,
Yeah. But does that work?
it works, I think, to a very large extent. There are certain observations that predict other phenomena, and you cannot fail to predict rain if you see, let's say, cirrus clouds come in, and then you will see the lower clouds, and eventually you get rain.
Having said that, there's a swing back to the scientific, though, wasn't there, Richard? Because we come into the 20th century, and I'm told that the shipping forecast developed here and broadcast in the 1920s, that's been called the most accurate weather prediction of all. And that was done, we can say, not in inverted commas, scientifically. Why was it the most accurate prediction of all? How did it get to be?
Well, it takes very small localised sea areas, and it gives you incredibly precise, highly codified and very much agreed terminology with which to understand what's about to happen in the next 6 to 12 hours. So in a way, it's quite a modest... I mean, the way that it becomes accurate is by being kind of short range and very, very precise. So, for example, Rockall, Malin, Hebrides.
It's a poem.
It is a beautiful poem as well. It is both beautiful and true, and you can't ask for more than that. But it's the language of the shipping forecast. For example, southwesterly backing southerly 4 is a very precise expression, which means there's a southwesterly wind blowing at force 4 on the Beaufort scale, which is a moderate breeze. Backing means it's going to turn in an anti-clockwise direction and become a southerly breeze. Rain later, good, means that later has a very specific meaning, which is more than 12 hours' time. Soon means between 6 and 12 hours, and imminent means within 6 hours. So you've got
What does good mean?
Good means good visibility. You can see for more than 5 nautical miles. Doesn't mean that he's glad there's going to be rain later. But
the way you said it.
But the day-to-day weather forecasts on television are couched in the language of imprecision. When John Ketley tells you there's a chance it may get a bit blustery later, this isn't actually telling you very much. A chance? What kind of chance?
We're coming to the end now. Can I ask you all briefly to say, do you think that people like you are going to get much more of a grip on this, that it is going to be more available to, let's loosely call it, scientific method? Liebe, just to start.
Well, I think probably not. I mean, chaos theorists are claiming that it's not possible, and I think if we believe them, then we believe also what Aristotle had to say. Very, very difficult material to work with.
Vladimir.
Well, certainly it's impossible to predict the weather within any period of time with the absolute accuracy, but the existing models these days, the sort of regional models, are able to do a very good job and predict rain, especially if you're using the technologies such as Doppler radars or satellite pictures and so forth.
Even if we got good at predicting weather, we'd still be rubbish at being prepared for it. We'd still be brought to a complete halt by 2 inches of snow, because anyone who had snow tires on their car would be regarded as a show-off.
Oh, well, ending on the note of gloom about weather, which cheers us all up always in this country. So thank you all very much for taking part, and thank you very much for listening.
We hope you've enjoyed this Radio 4 podcast. You can find hundreds of other programmes about history, science and philosophy at bbc.co.uk/Radio 4.